Good day everyone, this is Sir ARJIE LEYSON, one of the Mathalinos teachers. Now today class, we will discuss all about combined variation. Now last time, we discussed also the inverse variation, direct variation, and joint variation. Now let's define first what is combined variation. This kind of variation involves both direct and inverse variation. Thus, if y varies directly as x and inversely as w. Now we have here an illustration given that y varies. When you say varies class, that means the value of that will be k. And directly as x, then you will multiply as x. And inversely as w. So that means your denominator will be your w, or your value that represents in this denominator. Okay, let's have this illustration. Let's try to translate. Number 1, translating statements into mathematical equation using k as the constant of variation. A. P varies directly as A and inversely as B. Now given, we have here T is equals to varies, that means you will write the constant k first. And then directly as A, that means you will multiply by k by A. Over inversely, that means inversely as B, that means B will be your denominator. Okay. So next we're going to find k. So we have k. Now using the equation given, so we have P equals k times A over B. Now we're going to cross multiply to find k. So we have P times B is equals k times A. Now divide both sides by A. So we have here the remaining value in the right side, we have k. So you can write that as k equals P times B over A. Okay, do you get it? Now let's try to illustrate this, the letter B. Okay, y varies directly as x and inversely as the square of z. So we have here y equals directly. So varies, that means you will write k directly as x. So that means you multiply k by x. And inversely, that means you're going to write that as the denominator, which is the square of z. So we have square of z. Okay. That's how you write to translate the variation given in this statement. So next, we're going to find k. Same as we're going to find k. Okay, how are we going to find k? So we will use again the given equation. So we have y is equals k times x over z squared. So next step is cross multiply. So we have y times z squared equals k times x. Now given, so what we're going to do here is dapat the right side will remain lang is k. So you need to divide both sides by x. Cancel x, x. So we have k equals y z squared over x. We have example number 2. The following is an example of combined variation where one of the terms is unknown. We have question letter A. If z varies directly as x and inversely as y, and z equals 9, and x equals 6, and y equals 2, find z when x equals 8 and y equals 12. So we have here the solution. First, we need to solve for k by substituting the first set of values in the equation. So we need to write the equation first. First, we have to write z equals varies, that means you need to write the k as constant. directly as x, that means you need to multiply that beside k, and inversely as y. So you need to write y as your denominator. So we have here the equation z equals k times x over y. Now next, we need to substitute the first set of values in the equation. So we have z equals 9, x equals 6, and y equals 2. So we have here 9 equals k 6 times 6 over 2. Now next we're going to do, we need to cross multiply. So we have 9 times 2 equals k times 6. Then divide both sides by 6. So we have k equals to 9 times 2, we have 18 divided by 6. So 18 divided by 6, so we have k equals 3. Now we have the constant term, that is 3. Now next, we're going to solve for z using the equation. So we have here z equals k times x over y, where your k is 3. So we need to substitute. Now we have the given k equals 3 and 8 equals x equals 8 and y equals 12. So we have here z equals 3 times, we have 8 over 12. So we have 3 times 8, we have 24. Divide 12, so we have z equals 2. Okay, let's proceed to question B. So if y varies directly as n squared and inversely as t, and y equals 42 when n equals 3 and t equals 9, find y when n equals 6 and t equals 21. So solution, substituting the first values in the set of equations. So we will write the equation first. So if y, we need to write there, y equals varies, that means you need to write k directly as n squared, that means you need to multiply n squared beside k, and inversely as t. So you need to write t as your denominator. Now, next you need to substitute the given values in the equation. So we have here y equals 42. So 42 equals k. And then we have here our n, we have 3 squared over t is 9. So we need to simplify na lang the right side in our equation. So we have k equals 9 over 9. So 9 divided 9. So we have here the remaining value of our k is 42. Now next, we need to solve for y using equation y is equals to k times n squared over t. So we have here the given k as 42, n as 6, and t as 21. So we need to substitute the given values in the equation. So we have y equals 42 times, we have 6 squared over 21. So we have y equals 42, we have 6 squared, that is 36, over 21. So we have 42 times 36, that is 1512, 1512, over 21, divide 21, so we have y as given, the value is 72. So we have here our third example. Given we have w varies directly as x and y and inversely as b squared, and w equals 1200 when x equals 4 and y equals 9. And b, we have equals 6. Find w when x equals 3, y equals 18, and b equals 9. So we have here, we need to substitute the first values in the equation. First, we need to find the equation. So we have here w equals direct varies, that means you need to write k directly as x and y. So you need to multiply x and y with k. So we have here n inversely as v squared. So the denominator will be v squared. So we have here the equation. Now next, we need to substitute the first values in the given equation. So we need to substitute w equals 1200, x equals 4, y equals 9, and b equals 6. Okay, so we have here the given equation na. Now, next step we're going to do is we need to substitute the values, the first values in the equation. So we have here w equals 1200, x equals 4, y equals 9, and b equals 6. So we have here 1200 equals k times 4 times 9 over 6 squared. So we have here, simplify the terms in the right side. So we have k equals 4 times 9, we have 36 over 36. So pwede man siya ma-simplify, 36 over 36. So we have 1. So we have k equals 1,200. Okay, next is we need to solve for w using the equation w equals k times x times y over v squared. So we have here the given k equals 1200, we have x equals 3, y equals 18, and v equals 9. So we have here 1200 times 3 times 18 over 9 squared. So we just need to simplify the given terms in the right side. So we have 1200 times 3 times 18. So 9 squared is equivalent to 9 times 9. So 9 here, we can simplify 9 and 18. So we have 1 and 2 here. 9 and 3, so we have 3 and 1. So 1200 also can be simplified with, in the denominator remaining, we have 3. So we have 3, 1, we have 1200, we have remaining 400. So that means we have the remaining values, 400 times 2, so we have 800. So we have here our last problem. We have a word problem. The force of attraction F of a body varies directly as its mass m and inversely as the square of the distance of d from the body when m equals 8 kilogram and d we have 5 meters and f we have 100 newtons. Find f when m equals 2 kilograms and d equals 15 meters. Now we will write first the given. So we have here the given, the first set of values. We have mass 8 kilogram, the distance we have 5 meters, and we have the force of attraction we have 100 newtons. And we have the second set of values. We have mass 2 kilogram and the distance we have 15 meters. So next, what is asked? So we're going to find here is the force of attraction. Okay, we will write now the formula of the given problem. So we have here the force of attraction F varies directly. So varies, we have K directly as its mass. So we have K times M over inversely as the square of the distance. So we have D squared. So we have the formula F equals to K times M over D squared. Now we will now substitute the first set of values to the given equation. We will now find the K first. So we have F equals to K times M over D squared. So we have here the given 100 Newton then we have K times 8 kilogram over 5m squared. So we will now simplify the given values. So we have here, we will change the Newton, the value of the Newton is equals to kilogram meter squared. Okay, we will change the value of the Newton. So we have here kilogram over meter squared. So we have K times 8 kilogram. So 5m squared. So we have 25m squared. And then now cross multiply. So we have here the remaining unit cancel meter squared. So we have 100 times 25. We have 2,500 kilogram equals kilogram K times 8 kilogram. Divide both sides by 8 kilogram. So cancel the unit. So we have here, we have the K equals 2,500 over 8. Okay, now since we've already find the value of K, now next we will now find the value of our force of attraction given that the mass is 2 kilogram and the distance is 15 meters. We will use again the given formula, which is F equals K times M over D squared. We will now use the second set of the values given. So we have F equals, so we have 2,500 over 8 as your K, and times what is our mass? So we have 2 kilograms over the distance. We have 15 meters squared. Okay. So we have here simplify. So we have, you can reduce 8 by 2. So we have 1 common nila is 2. We have 4. So we have 2,500 over 4 divided by, so 15 meters squared, 15 times 15, that is, we have 225 meters squared. Okay, now we will do now is to reciprocate the denominator, 225, so we have now 2,500 over 4 times 1 over 225 meter squared. So we have here the kilogram sign. And then, now we will find the, simplify the given. So we have here the common 2,500 and 225. We have the common 25. So we have 9. And here we have 100. So we have the remaining values here. F is equal to 25 over kilogram, 25 kilogram over 9 meter squared. So we have here the final answer, 25 kilograms over 9 meters squared as our force of attraction. Or we have F equals 25 over 9 newtons. That's all for our lesson about combined variation. Thank you so much for listening. I hope you will like and subscribe to our YouTube channel, which is the Mathalinos. Goodbye!